Experiment 4 is about Grignard reaction. Grignard reaction is a synthetic method to prepare alcohols from aldehydes, ketones, or esters. It is performed in anhydrous conditions, meaning no water, since Grignard reagents are sensitive to acids, water, oxygen, and CO2 in the air. It is a heterogeneous exothermic reaction occurring at the interface between two phases, the solid magnesium in the liquid solution, which is composed of diethyl ether as the solvent, and bromobenzene in this case. In this experiment, we are going to prepare a Grignard reagent, which is phenyl magnesium bromide, made from bromobenzene and magnesium solid in diethyl ether as the solvent. Diethyl ether is used to stabilize the Grignard reagent and to satisfy the magnesium's valence requirement for an incomplete octet. The Grignard reagent is going to be reacted with an ester, which is methyl benzoate, forming triphenyl methoxide magnesium bromide, or simply magnesium triphenyl methoxide, which on hydrolysis in the presence of an acid will form an alcohol, which is triphenyl methanol in this experiment. This reaction is for 2 lab periods. The first day is shown in here, the setup, and I'm going to now set it up, the Grignard reaction for the first day. So as shown in this diagram, that's going to be our setup. We have a stirrer, round bottom flask, a condenser, and then a drying tube with calcium chloride drying agent. I have everything in here under the hood, and I have the magnesium turnings, and then I have the bromobenzene, and then I have the methyl benzoate is the ester, and then I also have the solvent. Essential for the Grignard reaction is diethyl ether. It's drying under molecular sieves overnight or more so that we can maintain the anhydrous condition. However, this is already anhydrous diethyl ether. All the glassware, I have the cylinders at the back, and then the dropping funnel or the SEP funnel, and then the RBF were all dried overnight in the oven, including the condenser in here. So they're all clean, and then they're also dried overnight in the oven to make sure that it's anhydrous condition. So I'm now going to weigh the magnesium, and then I'm going to put it in the 100 ml RBF, and there's already a stir bar. I'm now going to weigh the magnesium. This magnesium turnings were actually dried overnight at 80 degrees C. I zeroed the boat, and then the weight of the magnesium turnings inside the balance is actually 1.011 grams. So write down, please, the weight of the magnesium is 1.011 grams. I'm now going to take out the magnesium turnings from the balance, and always close the sliding door and then press the zero. And then I'm now going to pulverize it slightly using the mortar and pestle so that I can expose fresh surface of the magnesium turnings so that it can react and make the Grignard reagent faster. Otherwise, it takes longer. So I'm just crushing it. I'm kind of cutting it. So I'm now going to put the slightly crushed magnesium turnings into the 100 ml round bottom flask using a funnel so that I don't spill it all over. And then I'm now going to go under the hood. So I will clamp it. So I put it above the stir plate. I measured 4.5 ml of the bromobenzene using the cylinder. And then I also measured 8 ml of the diethyl ether, and I'm now going to add both of these into the RBF. So I added the bromobenzene. I'm going to rinse this out with the solvent diethyl ether. So I added everything and then rinse again. And then I'm now going to stir it. So we want to see some turbidity, meaning that the magnesium is now reacting with the bromobenzene. So the magnesium metal will insert between the carbon and then the bromine in bromobenzene. So between the benzene ring and then the bromine, the magnesium gets inserted. This is now about 5 minutes of stirring, and you can see that there is some turbidity. It's starting to get gray, the solution, the ether. So I'm now putting water into the condenser. So this is water is going in here and then water out to the drain. So if I have the water on, it's going to go up. Okay, so, and then I'm now going to put it over because now it's starting to react. And then I'm going to put it over here. And then I'm going to also put the drying tube over here. So right now the reaction started. It's now getting some color, so that's because of the bromine. And so you see some of the reflux coming up, and this should be cold condenser, so it should have the water. So when it starts to be violent, so you see there's a lot of refluxing going on. And then I'm gonna put some of this to make it cold, to cool it. So I don't have a lot of, it's an exothermic reaction. So I'm gonna put more ice to cool it so I can control the reflux. So I'm now going to add more diethyl ether. This is about 12 ml. And then I'm going to use the SEP funnel. And then I'm going to put it over here. So I will take out the drying tube and then put it like that. And then I'm now going to add the diethyl ether slowly. So all the diethyl ether got added, and I'm going to take out this again because I'm going to put the next reagent in here. And the drying tube actually has a drying agent, which is calcium chloride, and this is cotton. Calcium chloride as a drying agent, it controls the moisture going into my system, and then there's also a cotton in here. So it's not entirely enclosed because there's an opening, but it's preventing moisture from going into my reaction mixture. So we're waiting for the magnesium to react as much as possible, and then we are going to heat this up to complete the reaction. And then basically this is the first step. We are making the Grignard reagent, which is the phenyl magnesium bromide. So at this point, the spontaneous boiling stopped. Take note that the diethyl ether has a very low boiling point, and the reaction is also exothermic. That's why it was bubbling so much. And then I cool it in ice water bath. Now it stopped bubbling, and I'm just stirring it at room temperature. I took out the ice water bath, and then I want to stir it for another 5-10 minutes. Doesn't bubble anymore. We're gonna heat it up. So after 2 minutes of stirring it at room temperature, it starts to bubble again. So if it becomes violent, I'm going to again put it in ice water bath. Okay. So I have it ready in here. So you can see it on the side, the evaporation and condensation. This is now the ester that we are using for the Grignard reaction, and this is methyl benzoate. So I use a pipette, and then I zeroed the vial inside, screw cap vial, and then I added over 2.5 ml, and that's about 2.494 grams. So write down the weight, please, to the weight of the liquid of methyl benzoate is 2.495 grams, the weight of the liquid. So I'm going to take it out, and that's going to be the methyl benzoate. It's clear. It's a clear liquid. It's an ester. So again, close the sliding door and zero the balance. So after about 15 minutes of stirring it at room temperature, it stopped bubbling, and now I'm going to heat it up for about 5 minutes using the sand bath. There's a sand in the thermowell, and I connected this to the transformer, and then I set it to 120 volts and about 35. So the setting here at the back is 35. It's about between 30 to 40. And we want to reflux it. And this is now our Grignard reagent, phenyl magnesium bromide. And the heating process after the bubbling subsided is to make sure that we complete the reaction. So you can see actually some of the magnesium turning small pieces at the bottom. And I'm still stirring it. So I still have the stir plate on. And then we are now heating it up. This is now about 5 minutes of boiling using the sand bath, and as you can see the reflux going on, evaporation, and then condensation using the condenser. So it's not drying because of the condenser. So now I'm gonna turn off the transformer off, and then I'm now going to unplug it, and then I will take this out. And then I'm going to add now the methyl benzoate. This is the methyl benzoate that we weighed out, 2.5 grams. And I'm now going to add diethyl ether, which is 8 mils. And then I'm going to put it in the sub funnel. So So in the sub-funnel, so I'm gonna put that, and then I'm gonna rinse it out with the solvent. And then I'm now going to add it, take it out, and then I will replace the drying tube and put it over, and then I'm now going to add. So I'm just dripping, drip, drip. So I'm going to immerse it in the ice water bath, because it's a little bit violent when I'm adding. So just to make sure, so now I can add more. So the color changed to like cranberry kind of color. So now I added everything from the sub-funnel. So now the boiling kind of subsided. So again, this is the stage in which I added the methyl benzoate into the Grignard reagent, which is the phenyl magnesium bromide. I refluxed the mixture of the methyl benzoate and the phenyl magnesium bromide for 15 minutes, again over the sand bath, and now I'm ready to turn it off. So this is the end of day 1, and I will now turn it off, transformer off, off, and then I will now take this stirrer off, and then, so I'm going to dismantle everything now. And I'm now going to store it for the next lab period. So, just gonna raise it up, and then I'm holding the flask so I don't drop it, and I'm gonna let it cool, and then, so, take that out, take this out. So we'll let this subside, and then I will cork it. So because I have some metal in here, I'm gonna cork it instead of the glass stopper, because sometimes it gets stuck, and then it's gonna be hard for me to remove it during the next lab period. So this is what I did as illustrated in the handout. So this is the start of the reaction with the magnesium metal, and then when the magnesium is slowly reacting, it turns gray, and then it turns brownish once the Grignard reagent is being formed, and then controlling the temperature, controlling the reaction using ice water. So we have at the end of day 1 is going to be the intermediate, which is the magnesium triphenyl methoxide. So this is that product magnesium triphenyl methoxide, or PH3COMGPR. This is actually that one now. So this is the magnesium triphenyl methoxide. So we will store this until the next lab period. So I'm just going to cork it like that and then store it for the next lab period. So I now label this as magnesium triphenyl methoxide. So this is now the product of the reaction of the methyl benzoate and the Grignard reagent. Day 2 of the Grignard reaction is now the workup, and this is product isolation. We are going to do liquid-liquid extraction. So this is the procedure in this page, and this is the schematic diagram or the flow chart of the extraction procedure till we isolate the product. After a week of letting it sit, this is now our product, which is the magnesium triphenyl methoxide. So we need 10% sulfuric acid, so we need about 50 ml of it. And then ether, diethyl ether, so I measured 10 ml. And then beaker, and then flasks. And then we're going to do some extraction. I will try to remove all the product and then transfer it into the beaker, but because it's very chunky, I will try to dissolve and then with ether and then sulfuric acid. So I will first try to transfer, otherwise if I put sulfuric acid in here, it's going to react with the magnesium and it will bubble a lot, and then it's going to release actually H2 gas. So we don't want that, so we want to be as careful as possible and try to take out the chunks. It's solid, it's chunky. So I first added ether, and then I'm now going to add sulfuric acid. And the sulfuric acid, if there's some undissolved magnesium, it's going to create H2 gas. And if it's all in the flask, it's going to bubble a lot. So I want to put everything into the beaker because the mouth is more open. So this is now sulfuric acid. So you probably heard that there's a little bit of reaction popping up because of some unreacted magnesium. So you heard, so you now see a lot of bubbles. Okay, that's actually H2 gas. So it's the magnesium, unreacted magnesium, reacting with sulfuric acid at this point. So there's a lot of reaction going on right now. It's the gas coming off. And then I'm going to add a little bit more in the flask to transfer everything. So I want to rinse the mouth, so I'm actually going to use this pipette. So this is 10% sulfuric acid that I'm rinsing the mouth so that I can transfer everything into the beaker. So I can actually add some ice in here so that it's not too bubbly, but I think it's okay. Yeah, so it kind of slowed down the exothermic reaction when I added the ice, but it wasn't too bad because I think already the unreacted magnesium is almost gone, but I want to get rid of that chunk, big chunk. And I'm going to, I think there's a stir bar that we need to remove. So I take out the stir bar, put it here. I'm now going to transfer the solution into the SEP funnel. So I'm now going to extract. Slowly swirl it and then release the pressure by opening the stopcock. So we performed some extraction last semester, so it's similar. So right now I have 2 layers. There's still a bit of chunks, a little bit of precipitate in here, but we'll try to retain it in the SEP funnel. But I now have the upper layer contains the organic compound, and then the aqueous layer contains all the salt and then the other byproduct. So right now I have the organic layer contains the triphenyl methanol, and then some unreacted methyl benzoate, and then the aqueous layer contains the salt, which is the magnesium bromide, and then magnesium hydroxide. So we don't need the aqueous layer containing the salt, we need the upper layer. So I'm now going to extract, remove, I'm now going to drain the lower layer, which is the aqueous layer, containing also sulfuric acid and then some of the magnesium hydroxide, inorganic byproduct, and magnesium bromide. So I'm now going to drain the aqueous layer. So you take out the stopper, and then you have to lower it a little bit, it's too high. And then drain the lower layer. So we don't need the lower layer, we need the upper layer, which contains our compound, which is a triphenyl methanol. So I close it, I close the stopcock, and I want to retain still the solid in here. So we're going to do additional wash with sulfuric acid to make sure that magnesium triphenyl methoxide has been converted to the alcohol. Measured 15 ml of the 10% sulfuric acid to make sure that I converted everything. So I'm just going to add here. I'm going to shake it, extract. So put the stopper, invert it to release the pressure. So kind of popped out. So it popped out. You can also release it here. So you heard that pop. So I'm going to add a little bit more of the ether because I want to dissolve the solid so that I don't lose it when I filter it later. So I'm just going to add maybe 5 ml, we'll see. So I'm going to add a little bit, 5 ml. So right now, after I drained the lower layer containing the aqueous layer, I now have the upper layer containing the ether and then also the product. The next step is we are going to wash this with salt sodium chloride. So it's just saturated sodium chloride solution. I'm going to measure 15 mils of the sodium chloride into this cylinder. So the purpose of this is what is called salting out effect. And the sodium chloride, because it's a salt, it makes the layer much more distinct. And just to rinse out basically the organic layer. So now it's clear, it's lightly yellow, and then the lower layer is just your salt and then the aqueous layer. I will now drain the lower layer, and the water or the aqueous layer we don't really need. So, okay, so we want the organic layer, and then I will drain it into a fresh container, and we are going to drain now the product with the ether in here. Okay, so we are now going to dry this over sodium sulfate. So I'm just going to scoop a little bit of sodium sulfate to get rid of the water. So this is just sodium sulfate anhydrous. It's a drying agent. So I'm just going to scoop here and cover the bottom. Swirl it and let it stand for, let it sit for about a minute or 2 minutes. This is now the ether layer, our product, and then it's sitting on the sodium sulfate. I cover the bottom with sodium sulfate to soak the water in the, because we did extraction, there's an aqueous layer, there's water layer, so I want to get rid of the water by soaking it in the anhydrous sodium sulfate, which is the drying agent. We are now in this part, so I'm drying now the solution over sodium sulfate, and we are now going to filter. Okay, so I have a filter paper in here, and I will fold it so that I have what is called a fluted filter paper. So the fluted filter paper makes it go faster. By folding it, you create a faster filtration. And then I'm just gonna pour it. Because I don't really need the sodium sulfate. I just need the organic layer with the product in here. So I'm just gonna rinse the container with a little bit of ether. And then also the filter paper. And then we're done with that one. So I'm going to transfer it here, because we want to evaporate that ether, and then while we're evaporating, it will also crystallize. If we add petroleum ether, it will make it crystallize faster. So petroleum ether, Grignard. So I will measure 25 mils of it. And then it should start to crystallize. So you can see some cloudiness. So we are going to evaporate slightly the ether to remove the solvent, and then I also added Grignard, and then I set the heater to about 30 because the boiling point of ether is really low. So the crystals actually is coming out already on the side. I boiled it for about 15 minutes, and there was at least 20 mils of the diethyl ether. So we're now down to a little bit more than 20 mils. So you can see that it's precipitating, it's actually boiling. Diethyl ether that evaporates first because it has low boiling point. However, the Grignard has a higher boiling point, so it should crystallize or precipitate out the product, which is the triphenyl methanol. I also put a boiling stick to control the heating of the solution, that it doesn't boil over. We are going to do vacuum filtration, the next step. So this is the weight of the filter paper. So write this down, please, 0.218 grams. This is now the product and I chill it in ice water bath. And then we're going to apply the vacuum. And I'm going to moisten this with a little bit of the solvent, which is petroleum ether. So the filter paper is flat to the bottom. So I'm just going to press it so that it's flat to the bottom. So I'm just going to scrape it a little bit with the boiling stick. So I want to transfer all the solid . So the crystals are almost white, it's off-white. Some of it went through, so I'm going to refilter this one. I have another filter paper here because I want to filter the precipitate that went through, and the weight of the filter paper is now 0.221 grams. It's 0.221 grams. So we are now filtering the precipitate that went through, and then we're going to analyze it later on. And this is now that precipitate. Okay, so we are going to do TLC of the two precipitate. We are going to let this dry, and then also the filtrate. So we are now going to dry this for a few minutes, and then this is now the product, the first filtration, and this is the triphenyl methanol. That's the first precipitate, and then the second precipitate is going to be this one, the one that went through the filter flask. And then we have now the filtrate over here. So it's slightly yellowish in color. And then we are going to do again TLC on that, and we analyze what's in there. These are now the samples after drying. So on the left is the first filtration. So I labeled it as product triphenyl methanol 1, and then the one on the right is product triphenyl methanol 2. So as you can see, the first one is more white, and then the second one, because this is the one that went through the filter flask and I refiltered it, it's slightly yellowish. And we are going to now weigh. So I now put the filter paper with the product 1 inside the balance. So I zeroed the both. And now the weight of the filter paper and the product is 2.140. So product 2, I took out the filter paper and also the product. And then I put it inside the balance. I also zeroed the both. And then the product and the filter paper are also inside. And then this is now the weight of that product 2 and the filter paper 1.287. So you're going to subtract the weight of the filter paper, the same thing as the previous one, which is product 1, subtract the weight of the filter paper. We are now doing the IR spectroscopy. So again, the software is Omnic. And then I already open it, and then we're going to collect background first. And then just click OK. And then at the bottom over here, it's gonna show you this spaces filling up. And then once it's all black, we will close the window. So basically this is just the air. And then we're just gonna do add to window 1, no, X. And then we're now ready to collect sample. So to collect the background, you just put the ATR pressure tower down, and then to now put the sample, you're going to raise this pressure tower and then put this to either to the left or right, and then we are ready to put the sample. This was our sample, so I just used a little bit of it using a spatula, and then I now put the sample in that sample holder, and I'm now going to put the ATR pressure tower so that we can run the IR. So click, and then we're now going to collect sample, this icon on top over here, and then I'm just gonna click it and then just do OK, and then another OK. Then it's again collecting 8 scans, so now we have the IR spectrum. So it's done collecting, so I'm just gonna do add to window 1, yes, check. And then I'm just going to label, so find peaks over here, and then click, mouse click, so that I can have a threshold, and I can now label. So labeled, and then full scale. So this is basically our spectrum. So you are going to assign absorption bands for this sample. So I'm gonna label this one also. So I label it, and then I pull it down here, and then label this one again. So you have this region, that region, and then this one, that one, this one, that one, all right, as well as that. I will save it as a TIFF file, and I will provide this data to everybody. This is now the saved product of triphenyl methanol as a TIFF file. This is the second product that I filtered, the one that is lightly yellowish in color. I want to check if there is a difference in terms of the IR spectra between the first one and the second one. So now I put a little bit of the sample after I clean up, of course, from the previous sample. So I put it in that sample holder. So now again, the ATR pressure tower, I will press the sample onto the plate so that I can run the IR. This is now our data for the second sample. Now you compare the IR spectra of the previous sample, product 1, and then also the second sample, which is this data. And then this will be saved as TIFF file, and then will be available to everybody. So again, we are going to clean the ATR sample holder so that it's ready for the next person, the next user. So again, isopropanol, squirt a little bit in the cotton, and then wipe it out, and then wipe out also the bottom, because it touches the sample, and then do a second time so that it's all clean. Okay, so clean, wipe it out, and then aerate it, and then it's clean, ready for the next person. We are now doing the TLC of the precipitate of the product isolated, and then so TLC is thin layer chromatography, and then we will also run the filtrate standard triphenyl methanol, and then the biphenyl, the side product. The developing solvent, the mobile phase, is dichloromethane ligroin 3:1. So I have here the dichloromethane, it's DCM or methylene chloride, and then petroleum ether ligroin, and then this is our mobile phase. So DCM, petroleum ether 3:1 mixture, and again DCM is dichloromethane, CH2Cl2. Petroleum ether or ligroin actually is a mixture of hexane, so I put here the condensed structure of hexane, CH3, 4 CH2s, and then CH3. So I already put in here in the jar the mobile phase. So I put 3 ml of DCM and 1 ml of petroleum ether, so 4 ml total. And then the other jar, the same thing. The starting point or the origin of my plate is going to be higher than the level of my mobile phase. So I measured it to about 1 centimeter. It's about 1 centimeter from the bottom, so that it's this mark here is the origin where we are going to spot. It's going to be higher than the level of my mobile phase in the jar. So we have the product 1, okay, in this weighing boat, and then as well as the product 2, which is slightly colored, And then I already put it in here in this tube. Okay, so that's product 1. And then product 2 over here. And then we're gonna have also a standard. So this is the standard triphenyl methanol. So we got it from the company long time ago. And then I also put a little bit of that at the bottom here. So I just scoop a little bit using a spatula. And then we have a byproduct which is called biphenyl. This is a product, this is a byproduct from the reaction. And I also put a little bit in the tube at the bottom here. Okay. And then the filtrate, after filtration, it's slightly yellowish in color. So I put a little bit of that also in here. So it's dissolved. Okay, it's the solution, it's the filtrate that went through. Okay. So now I'm going to dissolve this in DCM. Dissolve the samples in DCM, and then we are going to spot. So the triphenyl methanol is this sample. Just going to show you how it looks like. So it's powdery. So I dissolved the solid samples in few drops of the DCM. So they're all now dissolved in DCM. I also labeled the top as 1, 2 standard. So I lightly label it with a pencil, and then we have another plate which is standard, biphenyl, and filtrate. So I'm going to do first the first plate, and then just use the boiling stick to make a dot, to make a spot. So I will make the spot, I will put the spot not too close to the edge on the left or on the right. So it will accommodate, this plate can accommodate 3 spots. Don't make it too close to each other nor at the bottom because it will affect your separation. So I'm just gonna do like that and then spot it. So I know where that spot is. So I'm just gonna do 2 spots. And then the next one. It dries fast because DCM is pretty volatile. So this is now the standard. So this is the plate under the UV lamp, and you can see that I have a good decent 3 spots at the bottom of the origin before we develop the plate. So I will now put in the jar the plate, and then I'm just gonna use, so I'm using a forceps, and then I dip it inside and then immersed into the mobile phase, and then I will cap it, and then I will leave it, and then I don't touch it until it's ready to be taken up. So again, this is an ascending chromatography, TLC, thin layer chromatography, and you can see that the solvent is going up by capillary action. So the sample is now interacting with the mobile phase and then also the stationary phase. So it's by polarity. So if the solvent is more polar, it's going to move the spots faster up the plate, and if it's more non-polar, it's not going to move a lot. So the plate is ready, so I take it out, and then I will mark it immediately because the solvent front will disappear fast. Okay, so this is the height of my solvent front, the one that I mark with a line. Okay, so the second plate, I spotted a standard, biphenyl, and then filtrate. So the biphenyl, so the standard is still triphenyl methanol, which is in this blue test tube. And then the biphenyl is actually white. And then the filtrate is this one. Okay, so I already spotted it in here. And then I labeled it as standard, biphenyl, and then filtrate. And then the same thing, I'm going to put it in this jar. And then I leave it there. This plate actually has a fluorescent dye. So when we view it under the UV lamp, the sample interacts with that dye, which is actually embedded in the adsorbent, and then we're going to see the spots. So this is, the TLC is an ascending chromatography. So when you dip it, the solvent is going to go up and move. So the mobile phase is moving the sample up, and the sample is interacting with the plate, which is the adsorbent, the stationary phase, and then the mobile phase. So again, the thin layer chromatography has an adsorbent, which is the stationary phase, and we put the sample onto the plate, and the sample now will interact with the stationary phase and then with the mobile phase. So this is a normal phase chromatography. The adsorbent is polar, and then the mobile phase is going to be a combination of dichloromethane, petroleum ether for this case. So if you put more DCM, DCM is more polar than the petroleum ether, it's going to make the spots travel faster than if you have a less polar or non-polar mobile phase. So the plate is ready, so I take it out and then I will mark it immediately because the solvent front will disappear fast. This is the UV lamp, and then I have it on at 254 nanometer. There's a rocker switch in here, and then you can see through. Look at it this way and then take a picture. So the one on the left, the very first spot on the left is the product 1 on the first plate, product 2, middle one. The third lane is going to be the standard triphenyl methanol. The second plate on the right, again, the first spot on the left, there are 3 spots on each plate. So in the second plate, the first spot corresponds to the triphenyl methanol. The middle one, there's a spot all the way to the top, is the biphenyl byproduct. And then the third lane is going to be the filtrate. So you can see a lot of the impurities in the filtrate. And then the triphenyl methanol is actually in the filtrate. So again, on the left side, the left plate, the first spot, first lane, is the product 1, product 2. You can see that at the bottom there is a impurity, more impurities in the second lane, second spot. And then the third spot is going to be the triphenyl methanol standard. We are now doing melting point determination. So I put in a vial the sample product triphenyl methanol 1, and then the other product triphenyl methanol 2. And then I'm going to pack using the capillary tube, melting point capillary tube. So I will take again. So we've done this several times during the semester. And then I will take out one of these. So this is a closed end. This is open end. So I will scoop in the open end, the sample. So I'm just gonna put it in, and then, so it's granular. So I scoop some sample, and I will use this glass tubing open, and then I'm just gonna drop it on top to pack it. So I'll drop it one more time. Drop it one more time to pack it. And then I now have the sample in here. It's about 2 millimeter or so. And then I'm just gonna put a label. That's gonna be our sample. And then I already packed the other samples, so we have 2 samples that we're gonna be doing melting point determination. Another technique to determine the purity of the sample by melting point. This is now the melting point determination of the products that we isolated, and this is the melt temp apparatus. And I already have the rocker switch on. And then I put the sample, the one in front here, the white label is the product one. And then the other one, the green one, is the product 2. So I'm now going to set the plateau. The melting point of triphenyl methanol is about 160. So I'm going to set it to 155. So I'm pressing plateau and then the arrow up to about 155. Okay, and then we start. So it's going to heat up fast. So now, right now it's heating. So it's now ramping up to that temperature that we set. So the green one, the second sample, actually started to melt at 150. So remember that I ramped it up to 155 and it started to melt at 150. And not totally melted yet, but I'm gonna increase it to 160. So I see that the second sample actually melted at about 161. So it started to melt at 150 and completely melted at 161. And the first sample 1 is not melted yet, so I'm gonna increase it. So the first sample, the one that is labeled white, started to melt at 162 and then completely melted at 163. So you are going to compare the melting point determination data for the first sample and then the second sample that we isolated.